All right. Hi, everyone. Welcome to LeetCode Nights, our first one of this year. Today, we'll be doing the stacks topic. My name is Willie. If you guys don't know me, I'm a second-year software engineering student here at McMaster. I also have Luigi and Tanae helping me out here as well for this event. Luigi, I don't know if you want to introduce yourself.
Hi, I'm Luigi. I'm also a second year software engineering student. And yeah,
Tanae.
Yeah. Hi, and I'm today. I'm a third-year electrical engineering student. There's that.
All right. So yeah, let's just get started. For those of you who are at here live at the event, you probably click the join virtual event button on the DSC McMaster events website. But if you guys have, or if anyone else shared the Zoom link or something directly with other people, make sure you do click that button because it does help us track actually how many people are checked into the event, and that numbers will also get sent to Google. So yeah, if you guys haven't done that already, please do so. That button will just send you guys to this Zoom. But yeah, I'm going to pass it on to Luigi to start off the presentation.
all right. So we'll start with a little bit of motivation of why you would want to use a stack data structure. So typically when you think of a stack, in a literal sense, you might think of a stack of plates or stack of books, stack of papers, and typical examples of what you might have a stack of. And basically there's a couple operations or things that you can do with this stack. And the two notable ones are putting on top of the stack or taking something off of the top of the stack. And those are the only two operations because you can't easily access something that would be in the middle of the stack, for instance. Because in the case of the plate analogy, you wouldn't be able to access a middle plate without taking all the top plate off, and the top plate off, the top plate off, until you get down to that middle plate being the top plate, and then you take that one off. Next slide, please. Another example would be the Tower of Hanoi game. And in this case, each peg is basically its own stack. And basically, to play the game, you have to reorder the what are they called? Discs. You have to reorder the discs onto a different peg than what you start on. And to do that, you have to take the top peg off, put it onto a different peg. You take the top disc off, put it onto a different peg, and then you do that in a certain sequence without violating the rule that the smaller discs have to be always on top of bigger discs. And then you can eventually move all of the discs into the correct position from a different peg where they started. And this would be, and you play this game using a stack, right? There are 3 pegs, each of which is its own stack. Next slide, please. All right, so now that we've seen some practical examples, we'll show some concrete examples of how you might implement a stack in some various languages. And so, for instance, in Java, you would import the Java stack util, typical Java library, and then you would instantiate a new stack with the type of string in this case, but it could be any type you want. It could be an integer, it could be a double, any object, right? And then you push onto the stack. And pushing onto the stack is what I said, where you put something onto the top, right? And in this case, we're pushing first and then second as strings. And then it's important to note that when we pop them off, they'll come out in reverse order because the second was the second thing that we put on, and then it would be on the top of the stack at that moment that we pop it off. And then once we pop again, we'll pop off the first. So basically, it goes in reverse order. Also, it's important to note on the side, I have these other useful operations, which is the size, which will tell you how many things are in your stack, and then peek. Peek will just give you the top element without popping it off. Next slide, please. Same thing in Python. We're using here a Python list, and we have 2 examples here. They're basically equivalent, except for the first line where we're making a deck instead of a Python list. In this case, we're appending to the end of the list, which is equivalent to pushing, and then we're popping. And in the comments there, you see print second, print first, equivalent to the previous example. And then we have len of stack and stack -1. Those are other useful operations. Len of stack will give you how many items are in your stack, and then stack index -1 will give you the top of your stack. It's basically equivalent to pop, but it doesn't actually pop. It'll just give you what the value is. I have a note here that the deck will be faster than the Python list because decks are like implemented differently, and they're more efficient under the hood. But that's irrelevant for the purposes of this talk. All right, next slide, please. And finally, for anyone who enjoys C++, this is another example, although it's unimportant usually for most people. It's important to note here that top and pop are separate operations. Pop does not return the top element. And so, yeah, this is just if you want to use C++, then we have this example for you.
Yeah, so I'm going to be going over like the visualization of a stack. So if you can see like the image on the top right, that is what we'll sort of use to represent the stack. You can sort of think of it as like placeholders in memory, where the left is where you start and right being obviously index like 1, 2, 3, and 4 later on. So yeah, the first line in Python, instead of using dequeue, we're just going to use a Python list over here. So the first line just sort of declares the stack variable to be a Python list. And then whenever we append, we're just going to add it into the first slot. So if you can go to the next slide, Willie. Yeah, so you can see it's just going to append 7. And the next 4 lines are going to do the same. It's just going to add it sequentially right beside the 7. So there's 2, and 5, and then 8. And now we're going to actually call the stack.pop function. And whenever it's called, it's actually going to remove it and then print it out. So even if you want to access like the top of the stack, using stack.pop will actually remove it from the stack. If you do want to just access the top one, we have it in the previous slide, but it's basically stack with the index of -1. The next line over here will again pop at number 5, then you'll append on 4, and then you'll pop again, which will remove 4. So yeah.
All right, so that's all for the presentation part, and now we'll actually get to have you guys on LeetCode. So if you guys never used LeetCode before, I will visit this website here over here, or just go to LeetCode.com and make sure you guys have an account, so you guys can actually use the website. And this website is where you guys will be practicing doing these challenges that involve in some way using stacks. So as you guys can see here, just go on the website and input your information. Once you're on the website itself, at the top, you guys will see like a problems at like a problem tab at the very top. And you just select what kind of problem you'll be using. We'll be doing, we have 3 that we've selected for you guys. I'll be sending out in a second. But once you guys are on that website and you guys see the challenge on the left side, how you guys use this website is you choose your preferred programming language at the top there, as you can see highlighted. And you can basically, there's a variety of different languages you guys can select from, and to type, to basically to solve the problem. When you guys have the solution, there are 2 buttons at the bottom right, one being run code, which you can run to test some example test cases to check if your code works to solve the problem that's given to you. And there's also a submit button that'll work to actually submit your code. And then they have a bunch of secret test cases that they won't necessarily tell you, but it involves a lot of, it's usually like 20 different cases, and they'll also test edge cases as well. And you'll see how well you did and whether or not you did all the cases correctly, as well as how fast and efficient your solution was compared to other people who solved this problem as well. So these are the 3 problems that I'm going to be giving you. And so one of them is going to be easy, and then there's also a medium one and a hard one as well. If everyone can visit them, that's where you'll be using it. For those of you guys who will need help, we have mentors available here who can help you with that. So in the message I sent right before the last one is a link to our Discord event server, where we'll actually be using, where all the mentors will be there to help you guys and support you. Thank you. Thank you, Luigi. Let me share my screen and show you the Discord for a second. 1 second. Okay. I think you guys can see it now. So if you guys are on the Discord, yours will probably look more gray than mine. But as you can see, on the left side are all the different channels. There are text channels indicated by the hashtag that are beside them. And there's also voice channels that are indicated by the sound emoji. So for those of you who are using Discord, I did also repost the same LeetCode challenge links in the easy, medium, and hard challenge text channels if you scroll down. But there are also other voice channels if you need, if you want to like communicate with one of our mentors. If you can see, there's like a help room section towards the top on the left side. And if you click the voice channel that's at the bottom, it'll create a custom like private room for you. You'll see like a hand emoji, and one of our mentors will know that you guys are requesting for help, and we'll come join you in the call as well. And you guys can screen share and or do whatever. As you can see, Luigi kind of joined the call. All right, but yeah,